So this is an extension of the Pythagorean identity for trig functions, right? Sine squared plus cosine squared equals 1. All they've done here is say instead of like theta or x, they have 2x in here, but that's fine. And then they move the cosine squared to the right-hand side. Okay, and so we're trying to evaluate the indefinite integral, which means ultimately we want to take the antiderivative of this and find the function whose derivative is sine cubed 2x. All right, so at this point, if you try to go for a u substitution, you're going to get stuck probably, right? So if you go for 2x, that's not going to help because you'll end up with sine cubed. How do you antiderive that? If you go for sine of 2x, you'd get u cubed, which would be fine. But when you derive sine of 2x and try to replace the dx with the du, you'll end up with a cosine that shows up, and there's no cosine in the original, which actually leads into why this is helpful. So what we'll do is we'll take sine squared and we'll replace it with 1 minus cosine squared, and then we'll still have a sine left over. So it'll look like this. So we'll take a sine squared and replace it with this, 1 minus cosine squared 2x. And then, remember, I'll still have a sine left over, so sine of x to the 1 power, so sine of 2x dx. All right? So, okay. So then I'm going to pick cosine of 2x for my u. Again, I say this over and over again, but if you guess wrong, it's fine. Just pick something else, right? So if you'd picked sine, you'd find out that it's not going to work. So I'm going to pick cosine of 2x. When I take the derivative of this, I'll get du is equal to sine of 2x times 2 dx. All right, so I did the chain rule. Derive the outside, I get sine. Leave the inside alone, that's 2x. Times the derivative of the inside, which is 2x, so I multiply by 2, and then the dx is there at the end. All right, so this is close. Notice here I have sine of 2x dx, but over here I have this factor of 2. The way we handle that is we just slide that 2 over to the other side. Yeah. Yes, thank you. Good catch. So I'm going to move a negative 2 over, actually. So I end up with this. Negative 1/2 du, hey, is equal to sine of 2x dx. Now I could make the substitution. In place of this, I'm going to put negative 1/2 du. In place of cosine of 2x, I'm going to put u. And this is what the integral will end up looking like. It'll be 1 minus u squared du, and then don't forget I've got this negative 1/2. I'll just put that out in front of everything. Okay, so then at this point it's pretty straightforward to finish because you've just got you're just antideriving a polynomial, right? So you'll end up with this negative 1/2 times u minus 1/3 u to the 3rd power plus c. And then in place of u, we just need to get this in terms of x because it started off in terms of x. In place of u, we're going to put cosine of 2x. So I get this. Negative 1/2 cosine of 2x minus 1/3 cosine to the 3rd power of 2x plus c. Okay. So again, what we found here is we found the antiderivative of sine cubed 2x. Here it is. You can distribute the negative 1/2 through if you want, but I don't really care. Okay. And you can check that by deriving, but again, I don't really want to do that. So.